I will introduce Dr. Tung as an entrepreneur. Yeah, and he's very smart because in the investment or investing in the energy efficiency equipment, which is the heat pump. Yeah, in fact, he's now working in mainland China in his factory. And thank you for his time to speak to us. I pass the time to Dr. Tung. Yeah, maybe you introduce about yourself and also, yeah, about your business. Yeah.
Thank you, Felix. Thank you for Green Council to invite me in this presentation. So is my voice clear enough? So because yes. I'm far from Hong Kong, so I hope the internet is good enough to convey my message. So once again, thank you very much, and I will share my screen first.
Thank you.
Okay. So. Is my screen okay? Is it read? Can you read properly?
Yes. Yes.
Okay.
Put it in full screen mode. Would it be possible to free?
Yes. Okay.
Okay.
So
good. Thank you.
Thank you. My name is Dennis. I work in the air conditioning industry for many years, and in the recent more than 10 years, and I start my business in manufacturing of a heat pump. So my main objective is to design equipment and heat pump which can achieve energy saving in the air conditioning systems in Hong Kong. So I just introduced ourselves a little bit. So we are a heat pump manufacturer in the mainland China, and also we also provide solutions to our Hong Kong clients for green technology and energy saving projects. We have also innovative technology design. We have desiccant dehumidifications and integrated function of various equipments in Hong Kong in air conditioning. So here is our box, which I includes many examples of using heat pumps in buildings in Hong Kong in the air conditioning and hot water systems, which can save a lot of energy for the building. So we are also a designated local research institute as recognized by the Innovative and Technology Commissions, and we are specialized in heat pump and air conditioning research. So as today speakers mentioned that more than 60% of the energy consumed in Hong Kong is from the buildings in Hong Kong. And within each buildings, in non-residential buildings, more than 60% of the energy consumption is coming from the HVAC system. That means the air conditioning system is the major part of energy consumption in our daily life. And beside this, we provide air conditioning to our buildings. We also emit heat to the outdoor, to our environment. So 1 unit of cooling provided to our buildings, we have 1.3 units of heat rejected to our outdoor environment. That means our environment will be hotter and hotter, and we will not comfortable with the hot generated by our labor buildings. And at the same time, other than cooling for the building, we also have heating in the building. For example, dehumidification, which requires some heatings, and hot water also need heating to provide the hot water services. So therefore, in order to reduce the heat energy, the heat consumption, so we would like to find much better efficiency rate to locally recycle the heat energy. And as I mentioned before, air conditioning generates large amount of heat energy, and reject it to the ambient outdoor environment. So if we can recycle and reuse this heat energy in the building, so we can save energy as well as we can reduce the CO2 emission, and we can also reduce the global warming effect of our buildings. So, well, in Hong Kong, we have our government together with the EMSD already issued a regulation, which is a building energy code, which has specifications on the minimum efficiency of machinery and also the design criteria and also the material used to minimize the amount of energy used in the HVAC systems. So other than that, in order to further reduce the energy consumption in the building, so innovative design is much more demanding. And with the innovative design, we can reduce the energy consumption as well as we can provide a better environment for our future. And well, I would like to focus on heat pump because heat pump is currently a very effective ways to recycle heat energy locally inside the building. So I need to explain a little bit technical terms. So for heat pumps, we have already saying that heat pumps COP. All right, COP means the performance, the heat output divided by the input power. So for example, if we extract 2 units of cooling, including plus 1 unit of input power, we can have 3 units of heat output from the building or from the system. So therefore, we can only consume 1 unit of energy. We can have 3 units of heat energy from the system. Therefore, the COP will be free. So currently in the market, there are many kinds of heat pumps. The commonly used is air to water heat pump, which has a COP of 2.8 to 3.8. And a water to water heat pump, which has much higher COP, which is 4.4 to 4.5. So we can see that with the use of a heat pump, we can generating hot energy within the building with very effective COP or efficiency. So the benefit of using heat pump, well, it can provide cooling and heating simultaneously. And the most important is locally recycle the waste heat into a usable heat within the same location. So we don't need to have to do network or power network to transfer the heat, the energy from one location to another location, and also no need to have transportation, which also generate CO2 emissions. And at the same time, we can reduce energy consumption in the building, both electrical or in gas, and also reduce the waste heat emission to our ambient. So nowadays, actually, heat pumps are widely adopted in non-residential buildings, both in government projects and in private sectors. So here is a system demonstration in a building. So, well, basically, on the left side is the air conditioning system. On the right side is the hot water system. So a heat pump is the a media or an equipment to connect both air conditioning system and the hot water system, and it absorbs the heat from the air conditioning system and transfer to the hot water plant. So therefore, energy is locally recycled and used in the hot water side. So there is the function of the water to water heat pump. However, water to water heat pump has some limitations. So if the demand of hot water is much larger than the demand of the air conditioning, so the heat pump cannot function because in the winter time there will be low air conditioning demand, and there will be low waste heat generated, and but the hot water plant demand for hot water is high, is huge. But there is not sufficient heat moving from the air conditioning side to the hot water side. So therefore, water-to-water heat pump may not be good in the winter time if the air conditioning plant is not demanding too much. Therefore, we have another option is the bottom part is the air-to-water heat pump. An air-to-water heat pump, it absorbs the heat energy from the outdoor, from the ambient, and transfer the heat energy into the hot water system. So if we put 1 unit of energy into the air-to-water heat pump, we can have 2 to 3 unit of energy going into our hot water system. And that is very, very effective and very, very efficient. And it can simply replace the using of gas boiler or replace the using of electric boiler. So, okay, so this is the explanation of the heat pump hot water system. So nowadays we have very good heat pumps. So heat pumps have different temperature at their outlet with different COP. With a leaving temperature of 45 degrees, the COP will be up to 3.8. With higher temperature, the hot water temperature up to 90 degrees, the COP will be dropped a little bit. But although the temperature rise, the COP will drop, but the COP still have 2.1 to 2.2. That means I input 1 unit of energy into this system, and then I will have 2 units of heat energy for use in the building. So this is still benefit of using a heat pump for high temperature application. So before for heat pump, the temperature, outlet temperature is very low, 45 degrees Celsius, and later on 65 degrees Celsius, the heat pump hot water outlet. But nowadays, 80 degree hot water temperature outlet and 90 degree hot water outlet temperature is widely available, and that can be used for design of hot water system for very large buildings. Where large building, we have large system and we need to have a much higher temperature for the losses in the pipework and in the heat transfer unit. So water-to-water heat pump and the COP, you can see that the COP is much higher and also can also achieve a very high temperature hot water outlet temperature. So other than using the air conditioning plant to absorb the heat, there is also opportunity to use the condenser water, that is the cooling tower water, to absorb the heat for the hot water system. There is another method to reduce the waste heat emission to our ambient environment. So nowadays we have much more advanced in control and much more advanced in electronic technology. The controls for heat pumps are improving a lot. And as I mentioned before, there will be air-to-water heat pump and water-to-water heat pump. And also there will be limitations on the water-to-water heat pump. So in winter time, air-to-water heat pump will be much better in a very cold weather. Therefore, we have a total energy heat pump, which is combining the 2 functions of air source heat pump and water-to-water heat pump. So it can control by itself, it can modulate the amount of energy used and to meet the demand of hot water and also for the cold chilled water air conditioning system. So this can help us to reduce our effort to manually to switch over the systems for better performance. So this is the schematic diagram of a total energy heat pump. So there will be more one heat transfer units inside. There will be an evaporator, a condenser, and an oil air coil. So this is the combination of air to water heat pump and a water to water heat pump. So another example of using heat pump to recycle locally within the building for energy saving is the indoor swimming pool heat pump. As you know, in Hong Kong, the governments are now changing the old outdoor swimming pool into some indoor swimming pool for the people to enjoy. So as indoor swimming pool is very large, very big, and also very humid. So we need to provide air conditioning for dehumidification. And at the same time, warm pool water is required for the people to enjoy. So therefore, heating and cooling are occurred at the same time. And therefore, heat pump is very suitable to do the locally recycle energy. So here is a schematic which I would like to explain. So in the indoor pool, this is an indoor pool. The indoor environment is very humid due to the evaporation of pool water into the indoor pool hall air. So evaporation will absorb the heat from the water and becoming the vapor and then raise up to the air inside the swimming pool hall. And this humid must be treated, must be removed by using a air conditioning method to remove the humidity and try to keep the humidity down to a suitable level. So energy is used. On the other side, due to the evaporation of the pool water, the water is cooled down. The temperature drops and people will not feel comfort and need energy to maintain the pool water temperature. So the humidification process by the air conditioning system will generate heat, and this heat is to use to maintain the pool water temperature. And this is the completely recycle of heat energy within this system, and no need to put additional heaters to heat up the pool water or do heat up the air for comfort. So therefore, in this example, this is a very good example because air conditioning, cooling, and pool water heating are occurred at the same time. So as we mentioned before, the heat pump is to try to recover the heat for our other purpose and try to achieve energy optimization and to lessen the energy consumption and providing warm air to pool water and pool hall environment. So another example I would like to talk about is the desiccant dehumidification technology. Well, actually, desiccant dehumidification technology is not a new technology. It is quite old, but not widely used because it consumes larger energy than the traditional air conditioning systems. But nowadays, the technology changed. The desiccant dehumidification may be providing energy saving to our air conditioning system. So I would like to talk about the humidity in Hong Kong. So why people enter a commercial shopping mall or enter a restaurant and they will feel very cold inside. Why do people like to have a very cold temperature inside a building? Because Hong Kong is very humid. So high humidity in Hong Kong. So if the temperature is not low enough, the water vapor, the water content in the air is high, which is people's most feel not comfortable because of the humidity, and they need to set the temperature down to reduce the humidity level. However, temperature will be too cold. The air conditioning will be too cold, and people need to put more clothes on their body, or need to use some method to reheat the air to meet the comfort level. So, well, actually, another system which is very famous in all over the world is the designated fresh air system. A designated fresh air system is to treat the latent load and the sensible load of a building separately. Because we have, as I mentioned before, because we have Hong Kong high humidity. So if we treat the fresh air with a desiccant method to achieve a very low dew point, so we can use this low dew point fresh air to offset the latent load in the building. And then we can have another set of method to offset the sensible load of the building. So if the sensible of, well, actually in the building, the sensible load is quite high, quite bigger than the latent load in the building. If we can use a method of energy efficiency method to operate a sensible low air conditioning system, then we can save a huge amount of energy. For example, if we set the chilled water temperature at a much higher set point, we can save a lot of energy. So we therefore try to use a desiccant method to reduce the water content in the air, particularly in the fresh air, because every location needs fresh air. So we can use fresh air to reduce the humidity inside a building, and the remaining is the temperature, the sensible temperature, which can be achieved by a higher chilled water operating system, and this will save a lot of energy for us for the building. So therefore, integrated heat pump, the regeneration path, can achieve extended energy saving, and this is very useful in laboratory and food processing. So I would like to explain the principles, preliminary principles of this desiccant operation. So, well, actually, it's very simple. So our fresh air coming in, and it will go through a pre-cool coil, which bring down to 13 degrees Celsius, and then it will go through the desiccant wheel, which absorb the heat energy, and then the air leaving the desiccant wheel will be up, going up a little bit. If we want to put it down, and then we can put a post-cool cooling coil into it. So so that can achieve a very low dew point supply air. The most important part is on the other side, the regeneration side. So air coming in, passing through a electric heater or gas heater or other means of heating device, and this heating device will raise the air to up to 120 degrees Celsius, and this hot air going through the desiccant and will bring the heat absorbed, the water absorbed inside this desiccant water, bring it to the outdoor and take it out. So therefore, it continuously, therefore the coming fresh air will be dehumidified. Dry air will be coming out from this unit. So actually the most important part, the largest part of the energy consumption is the electrical heater in this location. So if we can replace this electrical heater with a more energy efficient means of providing heating, we can reduce a lot of this energy consumption for desiccant dehumidification. So later on, I would like to introduce is the nowadays the heat pump that can achieve a very high temperature. So, I would like to demonstrate the unit look like this, a very big unit look like this. All right. So for example, I will come back here first. So in this electrical heating element, nowadays heat pump can provide outlet air temperature of 120 degrees Celsius. So by using a heat pump to provide the heat energy to this regeneration process, the energy consumption of this dehumidifier, desiccant dehumidifier, will be much lower than before. And this could be an option we can evaluate in our HVAC system to see which method can provide overall energy effective to our building. So coming here is another example of using a heat pump to achieve energy saving. This is a fresh air unit. So so why we have this kind of unit, I would like to explain a little bit. Because in Hong Kong, for example, in a sport facility, in a classroom, a university classroom, we have a certain time of unoccupied period. So in this time, unoccupied period, the fresh air mainly coming from the outside will be treated as usual. The temperature will be very low temperature. Then the indoor environment will be very cold. However, the relative humidity is high because in physics, in air, when the temperature drops down, the relative humidity goes up. So in this situation, we need to have to reheat the air coming out from the primary air unit, and this consumes heating energy. So if we integrate a heat pump into a PAU or a AHU, so we can use the heat generated from the heat pump to heat up the leaving fresh air to achieve a very low relative humidity. So when we achieve a low humidity, we don't need to have a very low temperature set point. So therefore, the energy can be saved. So this is another example of using a heat pump to achieve energy saving for our buildings. So so this example is very useful for unoccupied period of space with unwanted high relative humidity in summer. And also it can reduce large amount of energy consumption of our HVAC system. It can also provide fresh air heating in the winter by using heat pump method for much better energy saving, and particularly very useful in sports hall and classroom. So for the heat pump development and the desiccant development, so as I mentioned before, so heat pump can achieve 120 degrees Celsius leaving air temperature. I think this could be found in the market in next year. And this very high temperature can give us a very good potential to think about innovative design in this building to achieve much more energy saving. And also integrate this heat pump into a desiccant dehumidification process can provide a better saving even at large. And with a designated fresh air system with very low dew point achieved from the desiccant unit, so our room temperature set point can be set at 27 degrees Celsius, which is very comfortable. And with very low humidity, this temperature will be very comfortable, and much energy can be saved if the temperature set point inside a building is set as 27 degrees Celsius. And also this heat pump can be used in food processing, for example, for drying the Chinese medicine and drying the seafood, and a lot of things that can be used for by heat pump for energy saving. So I think this is what I would like to share with you this afternoon, and I'm ready to take questions.
Thank you, Dr. Tung. We have some questions from the audience, but because of the limit of time, I can only cover two. One is, in fact, these two questions are related. Then I think I can ask at the same time. The question is there any heat pump application in the residential housing? Are there any constraint in the domestic application? The second question is there any centralized air and water distribution system by using heat pump in the domestic building? I think quite they are similar, but different aspects. Would you try to answer?
Yes. Well, actually, this heat pump technology can be used in the domestic residential area, buildings, homes, families. However, in terms of the cost effectiveness, which is not good because, in a year, in one family, the use of heat energy for shower, for cooking is not much. And with that small amount of consumption or demand, by using this system, yes, technologically, that is good. However, in terms of cost effectiveness, it is not much good because heat pump need maintenance, need a larger space to accommodate. Therefore, if the developer try to adopt a centralized system for a residential building, and that will be a very good idea and good direction for using this system in residential buildings.
But is there some kind of application in mainland China as far as you know?
Yes, in mainland China, yes. Well, in the colder region, and they use a lot because in the colder region, the cost effectiveness is very good. In the mainland China, especially in the north region, they almost the government give incentive to replace the traditional heating system by the heat pump system. So yes, good in the northern part of the China because the heating demand is large. However, in Hong Kong residential, the heating demand is not much as compared to the northern part of China. So therefore, the cost effectiveness is not so attractive.
Okay, we come to have a final question, a bit technical. Maybe you can also read it. Yeah, is pre-treating primary air to a water low RH before being drawn to an AHU has been discussed for decades. What may be the obstacle to further step ahead?
Okay, yes, this is a very good question. Well, actually, this designated fresh air system has been discussed for a very, very long time, and many successful cases has been reported. But the obstacle is the regeneration of a desiccant dehumidification. So as I explained before, the heat energy used for the desiccant dehumidification is quite large. So that is the obstacle for commonly use of a desiccant dehumidification. However, as I said earlier, so nowadays heat pump can provide a heat air up to 120 degrees Celsius. And this is very good for the dehumidification of desiccant units. So as heat pump is very energy effective. So by using the heat pump integrated with the desiccant technology, so the cost of the dehumidification will be much lower. And in overall, when we design a HVAC system for a large building, so we can try to evaluate. So this system may or may not provide a better energy efficiency for the overall system as compared to the conventional chilled water system.
Thank you. Thank you, Dr. Tung. Thank you for your time and your preparation for us. I understand you are in mainland China, and I hope on behalf of Green Council, thank you for your time presentation. And I also hope that you can sell more heat pumps such that we can have more energy efficiency product being applied.
Thank you very much for inviting me. Thank you.
Thank you, Dennis. Yes, thank you.
Thank you. Bye bye.
Thank you for your time. Yeah.